All right, so you should have the framework right now. Let's look a little bit at how it works. So there's a whole bunch of players that I've already implemented for you. And the main thing that you're interested in using is RunMe. RPS is the class that actually represents the logic of the game rock, paper, scissors. But let's sort of like walk through the RunMe class to see how it works. And what you're actually going to be doing is making new classes that represent rock, paper, scissors players with other strategies. So the first thing that happens is we create the rock, paper, scissors game. So that object is called game. And then we create our two players. We have a weighted random player here and a beat last move player. Let's see how these work. If you're on a PC, you can hold the control button and click. If you're on a Mac, you can hold command and click, and that will jump you to the class where this is defined. So here's weighted random player, and if I scroll to the top, it says this player has a fixed probability for each type of move. So you pass it two parameters. You pass the constructor two parameters, which are the probability that it'll play rock and the probability that it will play paper. And the probability it plays scissors is going to be like the remaining probability that isn't covered by those two. So here inside RunMe, you see I'm saying you've got a 70% chance of playing rock, 20% chance of playing paper, which means it'll have a 10% chance of playing scissors. So that's my weighted random player. And then every single time it moves, it'll generate a random number and figure out, based on these probabilities, what's it going to do. So the other player is the beat last move player, which you can probably guess what it does. Let's click on it. So here it says this player will always play whatever would have beat the previous move of the opponent. And this can only work because after playing around, the game itself actually tells your player what happened last round, and then it records it. But we'll look at that in a second. So total games is how many games we're going to play. Let's actually play 100 games instead of 1,000. And so then over and over and over again, I ask player 1, what are you going to move? I ask player 2, what are you going to move? Then I tell the game, here we go. Let's play a round where here's player 1's move and here's player 2's move. And then the game will report the winner. And the winner is either going to be player 1, player 2, or a tie. So then it will print out some statistics about kind of how many games have been won and so far and so forth. And then the most important thing for you when you make your own strategies in a minute is RunMe actually tells player 1, hey, we're going to save the last round's information. So here's what you just did. Here's what your opponent just did. And here's who won. Here's how it came out. So let's look and see how the beat last move player uses that information. So here I am. Talk about that in a minute. So here I am in beat last move player. You see in save last round's data, all it does is it takes the opponent move and it saves it into an attribute called opponent last move. And then the next time get move runs, we run a method that figures out what would we have to do to beat whatever is inside the opponent last move. The only reason that I set this to be a value is because you have to start with something. And the first time we play, we don't know what our opponent played because it's our first time playing them. So we'll just always start by playing to beat rock, which is probably not a good strategy. It might be better to just play randomly on the first move. But anyway, there you have it. So let's take a look. So what I want you to do right now is sort of tinker around with this a little bit. Go ahead and try and instantiate other strategies here. Let's see what there is. So there's the always rock player. Oh, wait, let's see how this came out actually. Sorry, let's run it. So if you run it, you'll see a bunch of games, and here I see player 1 is winning 21% of the time. That's the weighted random player. Player 2 is winning 58% of the time because its plays are intended to try and detect any patterns in player 1 and then move to exploit them. And so it's doing that, so it's winning a little bit more. All right, let's do the always rock player, an ever popular choice. Always rock player, which should take no arguments. So now the beat last move player should totally destroy the always rock player. Yeah. So player 2 is winning pretty much 100% of the time because player 1 is always playing rock. Cool. What else can we do? Fixed action player. Let's look at what that looks like. So fixed action pattern player. What you do is I'm going to make a new int And this is like a pattern in a, well, here, let's look at the constructor. So it says this player plays the same sequence of moves in a repeated pattern. The sequence is given by an int array passed as a constructor, passed to the constructor. Okay. You might be wondering, like, what are these moves? These moves are defined as these static final variables inside rock, paper, scissors. So you got rock, paper, scissors. So let's do that. Where was I? So run me. I want it to play rock, paper, scissors. I want it to play rock, and then rock again, and then scissors, and then paper. So it's going to play that sequence of moves over and over and over again. So let's run it. And you can see that player 1 is doing rock, rock, scissors, paper, rock, rock, scissors, paper, rock, rock, scissors, paper. So you can see that repeated action. And here's beat last move, trying to beat the previous move. And now player 1 is winning most of the time because of this particular sequence I've constructed. And I know that this player isn't going to move well if it's always just trying to beat the previous thing that happened. So you can go ahead and try some of these other ones. We've got, what else do we have? If you want to play, there's a human player, which will actually stop and prompt you at the console what you want to do. There's the stay if I win, switch if I lose player. You might recognize that strategy. And that's the last one. So go ahead, play around with this a little bit, see what you can do. Come back next time to understand a little bit more clearly how do you implement your own players.